Hello everyone, and welcome back to part 2 of exploring 8-bit CPU from inside. And last time we covered program counter. So that is the component that tracks the instruction which instructions to be executed next. But the question is, how does this CPU actually read and decode the instructions? So that's what we are covering today. So let's first go inside our project. Yeah. So this is the part which we are covering today. This is IR, or instruction register. So, what is IR? Think of it like CPU's reading glasses for instructions. So, let's explore its working. So, it is made using these 8D flip flops, which you see over here. So, one for each bit of our 8-bit instructions. So, you see this IR0 and to this IR7 here, each storing one bit. When the clock ticks and IRN is enabled over here, the instruction flows in from this data bus through this NOT gate for inversion and gets lashed into the flip flop, and then it is held steady. Below each flip flop, you see these AND gates and OR gate. So these create a tri-state output. They let us control when the IR puts its data back onto the bus or it stays silent. So, what is the result? So, you get to see the result over here. This is IR out from 0 to 7, is carrying the current instruction of the rest of the CPU to decode. So, so far that is the instruction register. So, now let's move out and go to a very interesting component. This is the control unit. So, now uh, what is control unit or CU? That is like CPU's conductor, like telling every component what to do. Like, yeah. So let's see what's inside. So let's get inside. So on the left, you see this step counter, which is 3-bit synchronous counter that cycles through the execution steps, right? So I have labeled these steps like T0, T1, T2, and so on. So each for the information over here, each instruction takes multiple steps to complete. Okay, so in the center you see this blue block. This is again the instruction register feeding onto the 14 to 16 decoder, right? So this decoder reads the opcode and activates one of the 16 output lines. So one for each possible instruction for our CPU to execute. So now here is the deal. You see all these NAND and you see all these AND and OR gates over here to the right. So this is actually called the microcode logic. So I also learned it today. Uh, I mean, while creating the project, each gate combines specific step signals that. So here, each gate combines a specific step signal with specific instructions to generate control signals, right? So that's the actual task of a CU. So let me explain how this actually happens. Like I didn't explain it properly. So you see here PC out. This might activate during T0 to put the program counter on the bus. Yeah. Then again, let's take another instruction, which is memory in. Yeah. So memory in might trigger during T1 to read from the memory. Yeah, that can happen. Again, accumulator out, this ACC out pin. This could fire during T2 for an arithmetic operation. So at the bottom, you will see all these system bus buffers that these handle data flow between different CPU components. Yeah. So the CU essentially translates a higher level instructions into dozens of precisely timed controlled signals that orchestrates the entire CPU. So a CU in short does the same task what CPU does for a computer, right? So this was it for this video. So we will also explore the all other components in this series. So see you later in the next part.